Hello, mathematicians. Today we're going to be learning about fractions, more specifically about comparing mixed numbers. So before we begin, let's go over equality and inequality symbols. So here we have an equal to sign, which means equal to, and that means that both numbers at both ends of this symbol are equivalent to each other. Then we have the greater than symbol, which means that the first value we're given is greater than the second value. And then we have our less than symbol, which means that the first value we're given is less than the second value, right? So here we have our first example, which is 4 1/3 and 4 2/5. Now, this is harder to compare because our denominators are different, so we're going to rewrite equivalent mixed numbers that have the same denominators to make it easier to compare. Meaning, we have to find the least common multiple between our denominators, which are 3 and 5. So, in order to find the least common multiple, we have to find the multiples of each. So our multiples of 3 are 3, 6, 9, 12, 15, and so forth. And our multiples of 5 are 5, 10, 15, 20, 25, and so forth. So the smallest multiple they have in common, our least common multiple, is 15. So we have to take both these mixed numbers and rewrite them with a denominator of 15. So we're going to start off with 4 1/3. And in order to get a denominator of 15, we have to multiply the denominator 3 by 5. And whatever we do to the denominator, we have to do to the numerator as well. So we're going to rewrite the whole number, which is 4, because we're not doing anything with the whole number. And 1 times 5 is equal to 5, and 3 times 5 is equal to 15. So 4 1/3 is equivalent to 4 and 5 over 15. Now, we're going to take our second mixed number, which is 4 2/5, rewrite it, and now we have to find an equivalent mixed number that has a denominator of 15. So our denominator here is 5, and in order to get a denominator of 15, we have to multiply this by 3. And whatever we do to the denominator, we have to do to the numerator as well. So we're also going to multiply the 2 by 3. So the whole number we leave alone, it's just going to stay as 4, but 2 times 3 is equal to 6, and 5 times 3 is equal to 15. So 4 2/5 is equal to 4 and 6 over 15. Now, we have two mixed numbers with the same denominator. We have 4 and 5 over 15, and 4 and 6 over 15. And because they have the same denominator, we can easily see that 4 and 5 over 15 is less than 4 and 6 over 15 because we have less parts. So that means that 4 1/3 is less than 4 2/5. Right? So let's do another example. Here we have 5 and 5/8 and 5 3/10. And notice that the denominators are different again. So we have to find the least common multiple of our two denominators to write equivalent fractions afterwards. So before we find the least common multiple, we have to list out the multiples of our denominators. So our multiples of 8 are 8, 16, 24, 32, 40, and so forth. And our multiples of 10 are 10, 20, 30, 40, 50, and so forth. And notice that the smallest one that they have in common is 40. So we're going to take these mixed numbers and rewrite them so that they have a denominator of 40. So we're going to take 5 and 5/8, rewrite it, and in order to get a denominator of 40, we have to do 8 times 5. And whatever we do to the denominator, we have to do to the numerator as well. So the whole number stays the same, which is just 5, but 5 times 5 is equal to 25, and 8 times 5 is equal to 40. So 5 and 5/8 is equal to 5 and 25 over 40. Then we take 5 and 3 over 10, and we rewrite it. In order to get a denominator of 40, we have to multiply 10 by 4. Whatever we do to the denominator, we have to do to the numerator as well. So 3 times 4. Now the whole number stays the same, which is just 5, but then 3 times 4 is equal to 12, and 10 times 4 is equal to 40. So 5 and 3 over 10 is equal to 5 and 12 over 40. And now we have two fractions that have the same denominator, 5 and 25 over 40, and 5 and 12 over 40, which makes it easier to compare because 5 and 25 over 40 is greater than 5 and 12 over 40, meaning that 5 and 5/8 is greater than 5 and 3/10. Right? So here we have two other mixed numbers. We have 3 and 4/5 and 3 and 20 over 25. So our denominators are different, so we have to make sure that they're the same. So we're going to find the multiples of 5 and 25 and then find the least common multiple. Our multiples of 5 are 5, 10, 15, 20, 25. And our multiples of 25 are 25, 50, 75, 100, and 125. Now, our least common multiple between 5 and 25 is 25. So we're going to take 3 and 4 over 5. And in order to get a denominator of 25, we have to do 5 times 5. Whatever we do to the denominator, we do to the numerator as well. So the whole number stays the same, which is 3. But 4 times 5 is 20, and 5 times 5 is 25. Now, if we look at our second mixed number, it already has a denominator of 25, so we don't have to do anything towards it. And we have 3 and 20 over 25 and 3 and 20 over 25, which means that these two mixed numbers are equivalent to each other. All right, so finally we have 2 and 1/3 and 6 over 7. Notice that we have a mixed number here, but here we just have a fraction that's by itself. So because we have 2 and 1/3 and we're comparing it to just 6 over 7, this one is greater because we actually have a whole number here, whereas here we don't, making this automatically smaller and we don't have to change our fractions at all. And that's it for comparing mixed numbers.